So thank you so much. I'm gonna cruise through my presentation and about what I do. I'm gonna go through a significant background, and then I'm gonna present about selected research projects. So it's unbelievably incredible that we still do agriculture like this in the 21st century. Basically, just like we have been doing since the onset of agriculture, slash and burn, we add irrigation, fertilizers, and a package of different synthetic inputs to produce commodity foods that are worth not much for the farmer. So that requires a great scale. And that food goes mostly to feed animals in confinement with the cruelty that entails. And that's mostly enabled by cheap fossil fuels. And this model leaves behind contaminated soils and food supplies and drinking water. And the most incredible thing is that, is to produce cheap and fast food commodities, and it's subsidized by taxpayers like you and me. And if you look at the maps, I collected a few maps of the United States, percent farm sales, and most of these subsidies, go to farms that are large farms in the Midwest, and these farmers are able to get government payments for using a model of agriculture that is damaging the planet, damaging water supply and soils and the food supply we eat. And these subsidies could be shifted to a more benign or regenerative agriculture, because I also did some research on money that government money that other people get from federal funds, and you see the regions where this money is channeled to. So there is a big upside down problem here, because we are subsidizing a model of agriculture that produces a lot of externalities, and instead of supporting a model of agriculture that produces a lot of ecosystem services and makes farmers more resilient economically, environmentally, and socially. So quickly, we are losing, and this data is outdated because it's from 10 years ago, but we are losing about 2,400 tons of soil per second. This is every second losing soil because of the model of agriculture that we're doing. Another shocking data, we are desertifying about 1,300 hectares per hour. And, land is been going down on a per capita basis as we increase population in the world. And this loss of soil is like losing a country like Costa Rica every year. So how can we use farming practices that are regenerative of the soil so that the soil can sustain us all? So since 1950, there is a drop of 1% in mineral and vitamin per year in fruits and vegetables because of that model of agriculture. If you imagine a soil structure, the large circle is a grain of sand. The second darker circle, is a grain of silt, and then the dot in the bottom is a clay. Why do I show these? Is to show how soil structure affects soil fertility and regenerative practices. Most of soils are productive because of soil life, and life is vast and immense under our feet. Is amplified by the rhizosphere, which includes fungal hyphae, but not only that, it includes predators like nematodes, protozoa, megafauna and macrofauna. And this brings me to explain sort of, what is the grazing lab? The grazing lab is a lab whose mission is to research soil health, pastures, and animals, but all together, not separating anything from each other, because everything is tied to each other. So in this mind map, I have some of the square boxes are the main projects I'm running right now in this grazing lab, and I'm running at a farm that is mostly pasture-based. So it's a multi-livestock farm, and everything is pasture-based. And this is the first harvest of beef, and you can tell the marbling, the bioactive fatty acids in this beef is very high, because these animals eat grass from cradle to crate. Why pasture-based? Well, because pasture is the least expensive feed. It grows for free. It requires management and knowledge how to manage, but it's also superior or comparable to other feeds for the animals. So why not? Why using cows to regenerate the soil? Because they are the perfect soil generators. They collect and shred huge amounts of organic matter, inoculate them with beneficial bacteria, filter rocks and bigger particles, and generate, many units of perfect soil. One animal units, or an adult animal can produce about 270 pounds of nitrogen per year, and around 100 pounds of phosphorus, potassium, and calcium. This is one animal. And then I also use a slew of grazing enabling ecosystem processes to support my recommendations to farmers, and those are the biocenosis, the saliva effect, the root leaf interdependence, cow-pie integration, the oxygen ethylene cycle, trophobiosis, transmutation, and this produces less soil aggression, less dependence on external inputs, less dependent on less influence from pathogens, more biological diversity, more net photosynthesis and slower respiration, and then more macro and micronutrient availability. I'm not going to go over this slide because I have more slides, but I'm basing myself on 5 soil health principles. Manage more by disturbing less. Reduce chemical inputs, meaning using natural nutrient cycles. And that doesn't mean using less inputs. Using the same amount of inputs to produce more food, but reducing the synthetic incidence. So respecting that the soil is a living organism, and it has many interrelations that we still don't understand. And we studied some of the processes like trophobiosis, which means that healthy soils produce healthy plants, which repel pathogens. Add diversity, plant and biological diversity. This is a welcoming soil health principle above and below ground, so that we can build infrastructure for microbe and life. Only for every pest that we find, there are 1,700 beneficial insects that play for us, for farmers. Grow living roots throughout the year. This is sort of a corollary of what I said before. It adds organic matter, it adds crop residues, it adds roots, interchange between roots and root carbohydrates and microbes. Keep the soil covered as much as possible so that the soil acts as an armor to the surface. And 5th, integrate grazing ruminants in high stock density. Graze each parcel for 1 to 3 days or Pastures need rest to recover before they are grazed again. And animals with higher nutritional requirements should graze the best pastures. If you follow these principles, you have a perfect system. And the system is on the very left, you have a continuous grazing setting with one pasture, undivided pasture, and animals roam freely in this pasture all the time for 3-4 months. So they degrade the pastures. As soon as you start subdividing, each of these parcels get occupied for 2 or 3 times a year. That means that they rest for over 300 days. And the impact is minimum and the benefits are maximum. And here are the root systems of a continuous grazing system versus a regenerative grazing system. You know, roots are much more developed. And of course, we know about, you know, the relationship between, you know, when to graze and when to stop grazing, because we need to respect the cycle of the plant. And when you graze before before the plant is developed, you start affecting the reserves of the plant. So, and if you wait too much, protein, energy, palatability, digestibility go down. So there is a point in time where you have to graze. No more, no less. Some selected projects. So this is in a farm in Charlotte. They welcomed research, and they invited me to become the research director of the farm. And I have several projects, you know, about, you know, soil health. I have long-term projects on soil health, grazing management, biological diversity, and high quality beef. Some of the projects here, I'm gonna quickly go over these. I'm not gonna read them. I'll let you glance over. And I'd like to jump into the long-term study on soil health, because I think it's relevant to this talk. So I have been measuring these soils since 2015. I did measurements in 2015, 2017, and in 2019. I'm gonna make another measurement in 2021. So every 2 years, I do a really in-depth measurement. And so in 2 years, from 15 to 17, the soil organic matter increased across the farm by 1.7%. And what does that mean? In terms of water production, and I'm saying water production, the water holding capacity increased to 9.3 million gallons or 37,000 gallons of water per acre per year. That is, the translation of that is that the soils are now able to absorb about 1.36 inches of rain per acre that they didn't absorb 2 years ago or in 2015. And then for every inch of water infiltrated, forage production per acre increases about 200 pounds. Also, for every inch of rainfall, for every 1% of organic matter, nitrates and phosphorus are lowered. In terms of productivity, what does 1.7% increase across 2 years means? It means 57,000 pounds of extra forage, or about 69 round bales, or the capacity to feed 28 additional animal units raised on the pastures. And this is a savings of about, you know, $4,000. And then I remark again that for every inch of infiltrated precipitation, there is 200 pounds of forage production per acre extra. So we want to increase organic matter so that this organic matter keeps bringing those benefits. And for now, we are increasing because the measurements from 2019 accentuated some of the fields, some of the organic matter on the field, on some fields. And that means that this 1.7% increase in soil organic matter add up to increase soil organic carbon, which translates into 4.5 metric tons of soil organic carbon per acre. Okay, over 188 acres, this means about 30,000 pounds of organic matter per acre. In terms of carbon, total carbon per acre, this is 17,000 pounds, which is about 8 tons divided by 2 years. That means 4.5 tons of total carbon per year. If we had a potential carbon market at $20 per ton times 188 acres, this farm would be receiving payments for about 30 grand a year in payment for ecosystem services. The relationships between live weight gain and cattle and methane production per kilo of cattle. So the more they gain, the lower the methane production. And this is a modeling exercise that we did a number of years ago that sort of estimated the greenhouse gas impact of switching to management intensive grazing in Vermont. And we realized that we can save 28 million metric tons of carbon, of CO2 equivalents. So with that, I leave you with, if you have any questions, please contact me or ask me right now. Thank you.